Good morning, everyone. Hope all is well. Hope everything's going all right. All right. So let's see. I think I got a few people still trying to connect. Good morning. Let's see, is everybody? All right, so hopefully you guys got these steps I sent them to you yesterday evening. So we'll try to walk through a few of these today. So as far as chapter 8 is concerned, talked about all of the definition and foundational stuff. So today we'll just walk through some problems. 8.1 and 8.3 were more like definitions and talking about the errors and all the stuff like that. So check out 8.3, see if you have any questions, but that's all definitions. 8.2 is where the calculation come into play and walking through these steps. So we'll do a few problems, walking through hypothesis testing. Then our next class will be open for you guys to ask whatever questions you want to ask. And then after that, I guess we'll just take this test, right? We talked about that possibly being next Wednesday, but once again, if questions run over or something along those lines, y'all agree we need an extra day, something, I don't know. We can push it back, but I won't know unless you let me know. So let's see how this goes, and then we'll go from there. So I sent you this document yesterday, testing hypothesis regarding the population proportion. So there are two different approaches. Notice you have these initial steps here, initial conditions up here. So the main thing here, if n times your population proportion, remember n is your sample size, times the population proportion times 1 minus your population proportion, it has to be greater than or equal to 10. So they may ask you to test that, and all that is just multiplying your numbers together. And if these three conditions are met, then we can follow our hypothesis testing. So, the sample is obtained by a random sample, and then sample values are independent of each other. So for the most part, that's going to be the case. It's just that they may ask you to test, this numbers, and I'll show you a problem in a second. So from there, you have three options. And we talked about this when we talked about 8.1. It could be two-tailed, left-tailed, right-tailed. The wording in your problem will dictate which one it is. So if it just says something about the researcher want to see if it's going to be different, then that would be not equal to, which would be two-tailed. If it says the researcher wants to test to see if it's going to be less than, then you will do your less than symbol, or left-tailed. And then if it says something about want to test if it's increased or greater than, then it will be a greater than symbol, or in other words, right-tailed. From there, we have our test statistic that has to be calculated. And notice that's calculated the same way, p hat minus p naught over the square root of p naught times 1 minus p naught over n. So that's your test statistic. That's your z-score that we're going to go to the chart with. And then from there, we'll either, for the most part, I think this class does the p-value approach. I didn't see one with classic approach. So I'll check to make sure. We're not going to use technology. We're going to use the chart. And then so from here, step 4, once we get our chart value, that p-value, if it's less than your significance level, your alpha, we reject the null hypothesis and never state the conclusion. So alpha is given to us in the problem, our significance level. If you were doing this from scratch, you would choose your own alpha. Remember, we talked about that, last time we had a lecture as well, your significance level. But it's going to be given to us in our problems. All right, so let's look at a problem. Now, yeah, we're going to start here. Now, this problem is if they gave it to us, in other words, no wording. They gave us the null hypothesis and alternative hypothesis, and I had my eraser still on. All right, there we go. Now, I don't know what problem this was. I don't know why. I looked for problem number 22 in the test review, and it is not this. So don't worry about this part, but this is where we're starting right here. Okay, we're going to look at a problem that has wording and stuff, but right now let's just get the practice in. So we're starting right here. If they give us our null hypothesis is p equal to 0.5, and alternative hypothesis is p greater than 0.5. How we're going to walk through the steps from that point. So once again, they gave us this, and we're going to walk through the steps. Okay. So notice we have the greater than symbol. So that means it's going to be right-tailed. That means when we do our testing, we're looking at this, that's what it means to be right-tailed. So first thing we want to do is calculate our test statistic. And that's this formula right here. That's what I just showed you in the steps. So we're still following the steps. Haven't changed anything. Also in the problem, and yeah, they must have get, yep. So also in the problem, they gave us this, our p hat. Like I said, we're going to go through one that has the wording. I'm just walking you through the steps. We have p naught, and then p hat is calculated this way. You have your x, and then the sample size. And that ended up being 0.52, and the 6 is being repeated. All right, before we go to the test statistic, everybody okay with what we did so far? They gave us this. That wasn't anything for us to calculate. If they didn't give you p hat directly, then they have to give you x and n. So in this case, they gave us x and n. So you just divide 316 by 600, and you get your p hat. All right. So to find, what's going to be on the bottom of your Z naught or your test statistic, SE is 0.5 times 1 minus 0.5 all over 600. And that ended up being 0.020412. And so whenever you're doing your calculations, always make sure you're not rounding in your calculations. Notice I went to about 6 decimal places out. So you don't want to round that number to 2 or 3 decimal places, because remember, the further you truncate it, or the closer you truncate it, the more further you get away from the actual answer. And see, I wrote it right here. I don't know why I wrote it afterwards, but anyway. So you want to extend this out to maybe 5 or 6 decimal places. And then when you get to your final Z-score, that's when you're round to 2 decimal places. So remember, your Z-scores are always 2 decimal places. So notice I did the same thing here with my p hat. We found p hat to be 0.52, and then the 6 is repeated. Well, I took that repeating 6 out to about 5 or 6 decimal places to get the most accurate answer possible without, doing something real crazy. So while you're doing your calculations, you always want to go out 5 or 6 decimal places. Then when you get your final answer, you round it out to 2 decimal places. So your Z-scores will always be 2 decimal places. All right, any problems? I wrote this right here, so that was just a walkthrough. All right, questions before I scroll up? So we have our Z-score at 1.31. We're still going to our Z-score chart like we've done before. Yeah. So we got 1.3, 1.31. So that's 0.9049. All right, and so that's where I wrote the chart value. All right, so now to get the p-value, don't forget that is always dependent upon what type of test we're doing. And remember, we're doing a right-tailed test. So we need this piece of information, or how much information is to the right of that 1.31. Now, don't forget, chart value is always to the left So that's why we have to take that chart value, subtract it from 1, and that gives us the 0.095. All right. Everybody okay? Questions? Make sure we're good. All right, alpha is going to be given. And they gave us a significance level of 0.05. And before we go to the conclusion, just want to make sure we see where we can reference this. So right down here, it tells us its p-value is less than, so that's where I'm getting that from. If p-value is less than alpha. So if p-value is less than alpha, you reject the null hypothesis. So our p-value is 0.095. Our alpha was 0.05. So that's greater. So we do not reject the null hypothesis. So now we're going to have, problem to have wording. So we'll have to establish a conclusion, but right here we didn't. It was just a generic problem, just helping us walk through the steps. So all we would say is do not reject the null hypothesis. All right. Questions before we do another one. So that's the foundational process in a nutshell. When you add wording to it, then adds another element to it, but that's the process. So all right, so let's look at this one. We can go ahead and walk through this one, then we'll put some words on it. Okay, so this one, once again, I don't know what test review I was pulling this from, but anyway, let's start off with our null hypothesis being p equal to 0.18, alternative hypothesis being p not equal to 0.18. So now, if it's not equal to, then we're looking at two-tailed. I can do a little better than that. All right. So same process. This is always our P naught, our population proportion. So that's 0.18. P hat is always going to be X over N. So in this problem, once again, X and N was given to us. So it's 3 over 250, and that'll be 0.212. Then we will find our standard error. Which is the square root of 0.18 times 1 minus 0.18 divided by 250. Of course, if I scroll up too far, let me know. There goes our number for our standard error, the bottom number of our test statistic. Notice that once again, I took it out to 6 decimal places. Oh, somebody said something. Somebody asked, where did 53 and 250 came from? It was given. in this problem, it was given. So yeah. That should be given anyway, in some shape or form, but I'm pretty sure in this type of problem, they said x is equal to 53 and then n is equal to 250. All right. Can we scroll up? Everybody good? Okay, so then Z naught is P hat minus P naught over our SE. So that's 0.212 minus 0.18 over 0.024298. And that gives us 1.317, which as a Z-score would be 1.32. All right, so let's check this. A little tricky, a little more to it when you're talking about your two-tailed test. So I wrote a few steps on how we can establish what our p-value would be and how we would look at our z-score chart and all that good stuff. All right, so first we're going to take the negative representation of z naught. So notice we had 1.32. So what I'm saying is go to the chart with negative 1.32, because notice down here we need two z values. So we're doing 1.32 and negative 1.32. Remember, we use two tails, so we need two markers to establish our tails. So we're going to use the negative representation and go to the chart and get that value. And then we'll multiply that chart value by 2. All right, because notice what in my diagram, 0.0934 is what we get from the chart, but we also need 0.0934 to be on the right side of that 1.32. And it's symmetric, so whatever's on the left side of negative 1.32 will be on the right side of positive 1.32. So that's why we can just take that value, multiply by 2, and that will be our z-score. I mean, our p-value, excuse me. I rounded to 3 decimal places here. That may have been because of what MathLab was asking for, but always make sure you pay attention in any answer you give, that you give the decimal place that MathLab is asking you for. Questions? Any questions? All right, can we scroll up some? All right. So once again, alpha 0.05, it was given. And then we do our conclusion. If P naught is less than alpha, you reject it. But if it's greater than alpha, you do not reject your null hypothesis. All right, questions before we go to another problem? Try another one out. All right, so that's it for what I have written already. Let me go to MathLab and pull something up. Okay. Okay, so let's look at this. It says a researcher carried out a hypothesis test using two-tailed alternative hypothesis. Which of the following scores associated with smallest p-value? So we have z-score is negative 1.59, 2.49, 2.85, 0.15. So it says which z-score has the smallest p-value. So just want to make sure we have a visual on what's going on here. So 0 is in the middle. And of course, you got 1, 2, 3, -1, -2, -3, just giving us markers. Of course, you got the decimal values in between them as well. So if I look at, let's say 2, I have this much shaded that will represent my p-value if we were doing a right tail. But if I do 3, then I only have this much that would represent my p-value if I was doing right tail. Same thing on the negative side. This much would be my p-value. And then if I did the -1, then this much all the way down would be my p-value. So you notice -1 has a greater p-value than -3, or +2 would have a greater p-value than 3. So we go back here. It says which z-score has the smallest p-value, and it's going to be 2.85, and it's going to be the z-score that is furthest from 0. That should be it right there. Yep. So that's how you're doing your measurement on that. The z-score that's furthest away from 0 is going to have the smallest tail area, which means the smallest p-value. All right. Questions on what we did there? Just want to make sure we had understanding of p-values. All right. Oh, then this was everybody. Was anybody still copying, or is everybody good with that? All right. So let's look at here. This one, we have some words attached. In the mid 1800s, a doctor decided to make, and no, it won't do it that way. Okay. Doctor decided to make, the doctors washed their hands with a strong disinfectant between patients at a clinic with a death rate of 12.3%. The doctor wanted to test the hypothesis that the death rate would go down after the new hand washing procedure was used. What's the null and alternative hypothesis? So the key phrase here is going down. So don't forget, your null hypothesis stays the same, is going to be equal to. And then in this case, we're talking about decreasing or going down or less than or whatever. So that's this first one right here. The death rate remained the same. The death rate has decreased. So that's our alternative hypothesis, that is decreased. So notice these other options: death rate increased. That cannot be your null hypothesis. Your null hypothesis will always be the same or equal to. So that's always going to be the case. So anything different than that, is already wrong. Your null hypothesis is always going to be equal to, or in other words, the same. And then from there, your keywords will let you know what your alternative hypothesis will be. And since we talked about our death rate going down, that means our alternative hypothesis has to be decreased. All right, so once again, that's why this first one is it. And so the symbolism should reflect that same thing down here. So notice B could not be it because it has greater than in our null hypothesis. So that would not work. So that means it has to be A, C, or D. And it would, in this case, it would have to be A because we're talking about less than. And that'll be it. So in this one, all they wanted you to do was just establish what your null and your alternative hypothesis was. All right. Questions. All right. Let's see. Does this take us through it? Okay. So that one should be a good one. All right, so I'm gonna do all your homework problems for you. So we'll do this one, and it should be good to go. You know, walk through a few of them, walk through this one, and this will be all your steps. Okay, so historically, the percentage of residents of a certain country who support stricter gun control laws has been 54%. A recent poll of 986 people showed that 490 in favor of stricter gun control laws. Yep, I ran that together. But anyway, assume the poll was given to a random sample of people. Test the claim that the proportion of those favoring stricter gun control has changed. Perform a hypothesis test using significance level of 0.05. All right. So I'm going to take a picture and then, so I have to keep flipping back and forth. All right. So first, it says the population proportion that supports stricter gun control is 0.54. So this should be 0.54. And then let's see. We want to test the claim that proportion of those favoring stricter gun control has changed. So has changed is, in other words, not equal to. If it said less than, then you will use the less than symbol. If it said greater than, we use the greater than symbol. But it says has changed, so it doesn't matter whether it's less than or greater than, we use the not equal to. And then that's 0.54. Remember, both of those should be the same. All right. Questions before we go to the next step? All right, so significance level of 0.05. Choose the one proportion, z-test, chat bomb. Note the Sandler Rample, independent, large sample size. This is just telling us all our conditions are being met. The expected number of successes, failure, blah, 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 more than 10. And so we have to multiply this out. So N is, it says a recent poll of 986 people. So N is 986 right here. All right. So this is number 18. So this is number 18 on the test review. Hopefully the numbers won't change on me again. I don't know why those other numbers didn't work, but so that's what we have. Let me go ahead and write this. So our sample size is 986, and then it said out of that 986, 490 people showed favor in stricter gun control. So that means X is going to be 490. So it wants to do one. All right, so let's go ahead and calculate that out. Round to the nearest whole number. So he tells us to round to the nearest whole number as needed. So that should be 454. So once again, make sure you pay attention to those directions. 454, which is more than. Oh, let me just show you. This. Okay, so right here, 454, it said round to the nearest whole number. And then it said which is more than 10. That's your your initial condition going back to your steps. Notice it had to be more than 10. So that's where that 10 came from. All right. Everybody good? Everybody straight? So now it says find p hat. P hat is x over n. That's 490 over 986. So 49696. Let's see how many decimal places they want. 4. So they wanted 4 decimal places for p hat. All right, let me show you this. So they walking you through the process and they giving you steps. You know, so notice they're asking for the block right here. So there should be point. Yep, P naught 0.46. Check. And then they tell you to calculate the whole thing. So let's go back to the notes. All right, so all right, so that's our standard error. That's that bottom number of our test statistic. Now they tell us to round that to 2 decimal places. I mean, not 2, I mean 4. But when you do your calculation, leave it at 6 because, like I said, that will make your answer more accurate. So, but when you put it in, so just to show you what I mean. So they ask for 4 decimal places right here, but I would suggest when you do your actual calculation that you use the 6 decimal places. Let me see. So we can see transcript.
You had asked if we could see transcript while I was recording, right?
Yeah, somebody asked for it, so I just hit yes. I didn't do it.
Oh, okay.
Yeah. I don't know. Yeah, somebody just says like I got an anonymous request for it, so I figured somebody needed it. Maybe my mic not working or something. I don't know. You know, so yeah, so I just let it ride. I didn't know everybody could see it. I thought maybe just that person who requested it could see it. So yeah, so then we're just gonna put in points 497 70, and it should be 0.54. So that's what our stuff is, and then we'll go ahead and do our calculation. So let's go back to the notes. We're just showing you how we walking through the process. All right, let's see what happens here. 0.497 minus 0.4. So that's our z-score. All right, so that's good. So now we need our p-value. So we have to go to the chart first. Oh, make sure everybody's good on that. Zero, zero, 3, 4. All right, so we got 0.0034 for our chart value. So now we need that. Now the chart value doesn't necessarily, is not going to necessarily be your p-value. Remember, going back to our steps, we have, this is, yep, not equal to. So remember that means it's two-tailed. And so we got negative 2.71 over here, but then we have positive 2.71 over here. So right here is 0.0034, but that means also over here is 0.0034. So we're going to multiply that by 2. Remember, we only do this when we have two-tailed. Multiply by 2. All right, so let me show you this as well. Once again, pay attention to the directions, round to 3 decimal places. So you do have to watch it. You know, sometimes they ask for 4, sometimes they ask for 3. And you know, z-score is always 2. So you got to be careful. All right, so that means we need, or they wanted 0.007. All right, so before we do our comparison to our alpha, questions?
How come with this one, you don't subtract the right side from 1?
Because
z-score value.
Because the left side is right here, and that's what they give you, and it's symmetric about the mean or about the middle. So whatever's going on over here is going on over here. So okay, we can just take this value that we got and multiply it by, because you know both of them added together give us our p-value. So just multiply it by 2, and that'll give us, you know, the whole p-value that we need. But once again, that's only for when I get to it, that's only for two-tailed.
Okay.
That's only for two-tailed. Yep, no problem. Once again, let me go here too before we go to our conclusion. So left tail, if this was left tail, then we would have took that 0.0034 as our answer because it gives us the less to the left of. If it was right tail, then we would have done what your classmate suggested, which is subtracted from 1. So it's the same thing we did when we did our z-scores back in chapter 7. That was this, you know, that was like a foundational step to doing these hypothesis tests. All right. So going back to our hypothesis steps, if you go back down, it says that p-value being less than alpha is when you reject the null hypothesis. Sorry, I had some door activity. Somebody was going through the door, so I didn't want all that noise, you know, jumping in the mic. So, all right. So, oops, my fault. I was thinking it was 0.07. It's actually 0.007. So alpha is greater. So reject the null hypothesis. I'll just write H now. So once again, if your p-value is less than alpha, you reject the null hypothesis. And let's see what they're asking us to do. Okay, that's all they ask of us. So go back here. Reject the null hypothesis. The percentage is significantly different from 54%. All right. Excuse me. And we're talking about the percentage of your p hat. P hat was enough of a difference that it made, you know, all the stuff made us come to the conclusion that we came to with our numbers and everything. All right. Questions on anything we did? Any questions on the walkthrough? How we got any of our numbers? Everybody good? Everybody straight? All right. So we walked through 3 problems doing, you know, the steps. So now what you guys need to do is get in there and try it out. Next class will be open for you to ask whatever questions you want to ask. If you want to walk through hypothesis testing again, you tried it out, couldn't get it like you want to get it, try it again, or we can walk through it again next class. And then from there, let me go back to the notes. So remember, we had to get these proctor tests in. So next class would be the 11th. So 4/11, we're reviewing. If there are not any reasons to not have this proctor test, then we will go ahead and test on next Wednesday. And this is chapter 7 and chapter 8. And then also the same option will be provided for you, in which, you know, there will be a makeup that you can take advantage of if you're not ready for the test. Somebody said something in the chat. Yeah, no problem, no problem. So if you're not ready, hey, you just like, you know what, I'm just too far behind. You don't show up on this day, just like before, and the makeup will pop up at some point on that day after we've taken the test. And yeah, we'll go from there. And then we also have to talk about what we're going to do as far as chapter 9 and chapter 10 is concerned. You know, we'll talk about that next week, or maybe just a week after, you know, after we've got through this week of testing. Yep. So questions, concerns, comments before we close out today? Very good, very straight. Okay.
Thank you so much.
Yeah, no problem. Not a problem at all. You guys have a great weekend. Be safe. No problem. And I'll see you next class. Yep, you do the same. Take care. Take care.